Alright, I apologize. I've noticed in my videos there's a background noise because my fans are on because of the humidity in here. My fans and the AC in the background. So I apologize for that. Of course, this will be lost in time as this gets recorded and left down, and people will be going, why is he talking about fans and AC in the middle of winter while I'm just trying to do calculus? But such is life. So here we have a problem that we want to find the volume generated by rotating the region bounded by the triangle with vertices at 2, 2, 2, 5, 8, 5, rotated about the y-axis. So the first thing I am going to do is I'm going to draw this craziness. So I'm going to give myself some axes. And we'll label them. There's my y-axis. There's my x-axis, and I like having hats for axis. And let's find these points. So, did not like the blue coloring the other day. I found that really odd in the fill. So I'm going to try to get my colors a little more neutral. So let's see, 2, 2 is here. 2, 5 is up here. And 8, 5 is over here. And please recognize this is a right triangle, and later on we'll look at this using the theorem of Pappus. But if we knew where the center of mass of this was, we could use the theorem of Pappus. Pappus. Oh, please forgive my pronunciation. But what we're going to do is we are going to try to calculate a way of finding this. And I think, what was our rotation? About the y-axis. So we're rotating about here. So I need to take elements from here and rotate them across. I could use a cylindrical shell method, which means that I would be looking at my x element, creating my radius here, and x, and my height being these bits here. And so I could make cylindrical shells with these heights bounded by these two curves. So I guess I need to find out what these two curves are to set up my cylindrical shell. Right? So we will have our radius being the x variable here, and our height being the difference of, well, I'll call this f of x, and I will call this g of x. And so our height is the bounding of those. Well, this is a horizontal line, and it's at 5. So f of x is equal to 5. And this, well, we have 2 points. We have 2, 2 and 8, 5. So we can find the slope of this. So let's see, the difference in the y's, 5 minus 2 over 8 minus 2. All right. Is 3/6 or 1/2. So this line has a slope of 1/2, and using our point slope formula, y minus 5 equals 1/2 x minus 8. So 1/2 x minus 4 is equal to y minus 5, or y equals 1/2 x plus 1. So let's see, plus 1. Let me see if I come to 1, and I go over 2 and up 1. Yep, that gets me there, 2 to 2. So this is 1/2 x plus 1. So I have enough to set up my volume using cylindrical shells. So my volume using cylindrical shells is 2 pi times the radius of the element times the height times my delta x here, and or the width of the radius. So I'm going to turn this in the integral from 0. Oh, and so I need to integrate. I'm integrating across x. So I'm going from 2 to 8. So I'll go from 2 to 8 of 2 pi. I will move the 2 pi out front. 2 pi. My radius is x, and my height is 5 minus 1/2 x plus 1 delta x. So we'll clean this all up here. How did I enlarge this by mistake? I did not mean to do that. Let me see here. There we go. Bumped one of the buttons on my tablet. We'll bring the 2 pi outside. We'll integrate from 2 to 8. I'm going to do some simplification here. So 5 and 1 is 6. Oh, wait. Let me put this as minus in brackets. So it's 5 minus 1. That's going to be 4 times the x, because the x is coming through. And then in 5 minus 1/2 x. So minus 1/2 x squared plus 4x dx. Alright, I distributed the x. I have 5x, and it gets distributed through each term in here. Or I could simplify this up, negative 1/2 x plus 1 plus 4, because the minus 1 and the positive, and then distribute the x through. So I'll take my integral. Negative 1/2 x becomes x cubed over 6 with a minus sign, plus 2x squared from 2 to 8. So we're going to have 2 pi minus 8 cubed over 6 plus 2 times 8 squared minus a minus is positive, so it'll be 2 cubed over 6 minus a plus is minus 2 times 2 squared. I'm going to bring this up here. It's going to have 2 pi 8 cubed. Let's see, 8 times 8 is 64. I don't have a calculator. Oh wait, there's my calculator. We'll do that. Had to reach across the table. So 8 cubed is 512, and I divide that by 6. So I will have negative 512 sixths plus 128, because that's 64 times 2, plus 8 sixths minus 8. And let's see, I'm going to add 8 to this, and so I'm going to have 120 over here, minus 504 sixths. And I'll make this 6, so that's 720 sixths minus 504 sixths. So 720 minus 504 is 216. And let's see if I can do any simplification here. 2 goes into 6, leaving 3. 3 goes into 21. I get 72 pi, which is the answer. Yay, keeping the fractions.